Reactions of carboxylic acids. Yesterday we discussed two of them. Their reactions are similar to that of normal acids, but because these are weak acids, so reaction is relatively slower. So the first reaction was when acid was reacting with metal. Then result was, the product was salt and hydrogen. So example, if you have ethanoic acid, CH3COOH, and it react with metals such as example sodium. So as sodium is more reactive, so it will displace the hydrogen. It will form sodium ethanoate. The product will be CH3COONA plus hydrogen gas will be the product. And then balancing part, 2 hydrogen. So you put 2 for balancing hydrogen and you balance sodium acetate ion. This we discussed yesterday, balancing when organic acid reacted with metal. And the second reaction was when organic acid or acid react with metal oxide. This will result in a formation of salt and hydrogen, salt and water. So if you have organic acid such as ethanoic acid, CH3COOH, reacted with metal oxide, example magnesium oxide. So magnesium will displace this hydrogen, and magnesium is group 2 element, so valency is plus, so that's why CH3COO in a bracket 2 and Mg will be there.
These are the displacement reaction.
This is called neutralization reaction because when acid is reacting with metal oxide, we call them as neutralization reaction because salt and water is there, and water is a neutral product. When you balance this equation, because you need 2 acetate ion, so you put 2 acetate ion is balanced, magnesium is 1, that's balanced, hydrogen 2. All this equation is balanced in terms of all the elements present. This was what we did yesterday. Then another reaction of acid, when acid react with base. Base or alkali or metal hydroxide. This will result in a formation of salt and water. So salt plus water as a product when acid react with an alkali or acid-base reaction. So if we have like example CH3COH, that's acid. Ethanoic acid reacted with base or alkali such as sodium hydroxide. So again, a neutralization reaction. Why we call this as neutralization? Because acid is reacting with base. So and sodium will take position of hydrogen. So CH3COO Na plus H2O. Is it clear? This is when acid is reacting with an alkali, organic acid. So this is acid and it is reacting with a base or alkali. So when acid-base reaction is there, this reaction is categorized as neutralization reaction. And if any acid reacted with metal carbonate, then the result is salt plus water plus carbon dioxide. So same thing happened for these organic acids. When they react with metal carbonate, they result in a formation of salt, water, and carbon dioxide. So if you're taking ethanoic acid, CH3COH plus it is reacting example with sodium carbonate, Na2CO3. So it will form sodium ethanoate, the salt. The sodium will displace this hydrogen. So it will form CH3COONA, because the charge on acetate ion or any uh, oxalate ion is -1 and sodium is +1. That's why it will be CH3COONA. Plus water is there, water is H2O, and carbon dioxide is there, that's CO2. The second part is balancing the equation. To balance this equation, it's better you identical a group of atoms, you make one block like CH3CO together here, and CH3CO we represent by a gray shade. Hydrogen we are representing by a pink shade. So example, sodium representing by green shade, and this carbon and oxygen are there. I can use different shades. So CO3 is there and oxygen, this is already balanced. So basically we have to balance hydrogen. So we have two hydrogen in the pink shade and we have one hydrogen. So that's why we put two. So when we put two, hydrogen is balanced in pink shade. What about CH3CO in a gray shade? It's two on the left hand side. So we need two on the right hand side. So that's why we put two. So when we put two, CH3CO is balanced. Na is also balanced. You can see 2Na. Hydrogen is balanced, and carbon and oxygen was already balanced, which was in CO3. So this equation is balanced in terms of carbon, hydrogen, oxygen, and sodium. Is it clear? So this is a similar way they react. Acid react with metal carbonate. So when acid react with metal carbonate, it will give salt, water, and carbon dioxide. Which salt will be there? This is acid react with alkali. Acid is CH3COH reacted with alkali. So the reaction is called a neutralization reaction, in which it will form a salt and water. So what happened? Sodium is more reactive. So sodium will take position of hydrogen. So as sodium will take position of hydrogen, it will form sodium ethanoate, the salt, and water, H2O is there. Same way, if acid react with metal carbonate, the product is salt, water, and carbon dioxide. So sodium will take position of hydrogen. So it will be sodium ethanoate, the salt will be there, water is H2O, and carbon dioxide is CO2. For any equation, there are two things. One is writing a product, another one is balancing the equation. So first thing is writing a product. So you should identify what will be the product. Acid react with alkali, so the product will be salt and water. And how this salt is formed? When hydrogen is replaced by a metal, the substance which is formed is known as a salt. So the substance is a salt and H2O is water. Here acid is reacting with metal carbonate. The result is salt, organic salt, plus water, plus carbon dioxide. Then reaction of acid with alcohol. Basically organic acid, normal acids are not there. This is organic acid. Okay, you want to copy? So when organic acids are reacting with alcohols, this will result in a formation of ester plus water. But this reaction is a reversible reaction. What is the meaning of reversible reaction? It means that the reactant can form a product and a product can decompose and form back the reactant. The forward reaction, when we form ester, the forward reaction is called esterification. And the backward reaction is called hydrolysis. Esterification means formation of ester. And why the backward reaction is called hydrolysis? Because if you use water to break down something, that reaction is called hydrolysis. So here, when organic acid is reacting with alcohol, this will result in a formation of ester. That's why we call esterification. But if we have ester and we use certain conditions, that water can help ester to decompose. And if water help or ester to decompose, that reverse reaction is known as hydrolysis. So example, how this reaction occur? If you have any organic acid, say CH3, COOH, plus alcohol, so any alcohol example you took methanol, CH3 and OH. So this one is ethanoic acid. And the other one is methanol. So how this reaction will occur? The same way as you studied, that hydrogen of the acid is replaced Before that it was replaced by metal, but now in this case it is replaced by a carbon chain of alcohol. So this CH3, this whole CH3 will take position of hydrogen. So as this whole CH3 will take position of hydrogen, then what will be the product? It is CH3 COO. You can see CH3CO, and in place of this hydrogen CH3 took, so that's CH3. Plus this hydrogen which is removed will mix with OH, and H plus OH, what it will form? It will form H2O. So the carbon chain will displace the hydrogen of carboxylic acid, and now what it formed, you can see whenever COO is there, it means this class of organic compound is known as ester. And how to name ester? The part which is connected with oxygen is considered as a branch. So how many carbon atoms are there in a branch of this ester? So one carbon. We will use, if one carbon is there, we will use the term meth. And because it is a branch, so we will say YL. So it's methyl. How many carbon atoms in the chain? The main chain. So if there are two carbon atoms in the main chain, two carbon atoms are there in the main chain. This is a branch. And this one is a main chain. So branch was having one, that's why meth. And now the chain is having two carbon atoms. So if it is having two carbon atoms, so we'll use the word eth, because there are two carbon, they have a single bond N, and due to functional group ester, we call that as O8. So it will form a product methyl ethanoate. And it is easy to remember this, that the first name of ester, the first name of ester is coming from alcohol. And the second name the second part or the second name is coming from acid. So the first, like example, in this example, ethanoic acid was reacting with methanol. So what ester it formed? It formed methyl ethanoate. So first name is actually from the alcohol which reacted, and the second name is from carboxylic acid which was reacted. So sometime they give you the name of ester and they ask identify which acid and alcohol react to form the following ester. I will give example, more examples. First copy this one. Copy this one, then I'll give more examples. Okay, I can solve with the full open structure. That's not an issue. So if I represent all of the bonds, the reason why I was using the closed structures like the structural formulas, because it saved the space only. That was the only reason. Which acid is this? What's the name of this acid? 3 carbon atoms. So it is propanoic acid. And it reacted with example alcohol, so 2 carbon atoms in this alcohol. What we call this? We call that as eth because 2 carbon, N because of single bond, and OL because of OH, ethanol. As they react with each other, what happened? The hydrogen of this acid is replaced by the carbon chain, the full carbon chain. So this whole carbon chain will take position of hydrogen, and hydrogen will take position of this carbon chain. So what will be the result when I draw the structure of the product? So we have 3 carbon atoms first due to propanoic acid. Till this part, and then O is also there. Then what happened? This hydrogen is replaced by this carbon chain. So this bond will break with oxygen from this side, and it will displace this hydrogen. So it will form CH2 and then CH3. And then water, because H and OH will form a bond. So H and OH will form a bond, that H and OH means H2O. This is the final product. But what is the name of the product? We name the branch first. We name the branch first, and then we name the main chain. So how many carbon atoms in the branch? So there are 2 carbon atoms. That's why we call eth. This is ester. So because of 2 carbon atoms in a branch, we call that as eth. And because it is a branch, so we'll call YL. So it's ethyl. Then 3 carbon in the chain. So 3 carbon in a chain, we'll say prop because of 3 carbon. They have single bond. That's why it is how this is considered as a branch, because oxygen is separating them. The oxygen is separating, so the part which oxygen is separating, so C double bonded with O is considered as a main chain, and oxygen separates, so it become a branch in case of esters. So eth because of 2 carbon, YL, prop because of 3 carbon on the chain, and they have single bond, and because of this functional group, we call that as O8. So it is ethyl propanoate. Is it clear? And you can even identify from without the whole structure. You can identify, because if ethanol plus propanoic acid, So the first name is coming from alcohol, that's why it is ethyl. The second name is coming from acid, so it is propanoate, ethyl propanoate. So another example, if you have CH3, CH2, CH2, C double bonded with O and OH. That is carboxylic acid. Which acid is this? 4 carbon atoms. What is the name of this acid? Because of 4 carbon atoms, it is bute. They have a single bond N, and due to functional group C double bonded with O and OH, it's butanoic acid. Then we have alcohol, example CH3, CH2, CH2, and OH. Which alcohol is this? 3 carbon atoms in this alcohol. So because of 3 carbon atoms, it will be prop. They have a single bond N, and due to functional group OH, it is also propanol. What happened when carboxylic acid react? Their hydrogen is replaced. When carboxylic acid are reacting with alcohol, their hydrogen is replaced by the whole carbon chain. So this whole carbon chain will take position of this hydrogen, and hydrogen will be at their position. So the product which is formed in this reaction, so if I draw the structure, it is CH3, then CH2, then CH2, then C double bonded with O, and till O. So till oxygen of the carboxylic acid. So CH3, CH2, CH2, C double bonded with O, the whole carbon chain. So what happened? This whole carbon chain will take position. So we'll have CH2, CH2, and CH3. And the hydrogen plus oxygen, hydroxide. So what it will give? It will form H2O. So what is the name of this compound? How to name an ester? So to name ester, the part of a carbon chain which is attached directly single bonded with oxygen, that part of a carbon chain is known as branch. And the part of a carbon chain which is attached with C double bonded with O, that is considered as a main chain. So this part, this is a rule, IUPAC system, that the part which is having a single bond with carbon, that is considered as a branch, and this one is a chain. So how many carbon in the branch? Because there are 3 carbon in the branch, so that's why we call prop. And because there is a branch, so we call that as YL. So it is propyl. 4 carbon, so we say but, single bond N, and due to the ester group, we call them as O8. So it is propyl butanoate. So you can see the first name is coming from alcohol and the second name is coming from carboxylic acid. Is it clear? This is similar to the one when you can see here, the first one, the reaction was hydrogen was here, atom was there, but this atom is more reactive. That's why it was displacing hydrogen. You can see here the magnesium atom was more reactive. So magnesium atom was displacing this hydrogen. But in the other case, this when it reacted with alcohol, so the carbon chain is more reactive. That's why the whole carbon chain will take position of hydrogen. And this will result in a formation of ester. So in words, if we say, if we have butanol plus propanoic acid, what will be the ester form? Name the ester form when butanol reacted with propanoic acid. So the first name is always from alcohol and the second name is from acid. So what will be the product? It will be butyl propane O8 plus water. So you can see the first name of ester is always coming from alcohol, and the second name of ester is coming from carboxylic acid. So sometimes you have to complete a word equation like butanol plus propanoic acid gives butyl propanoid. Same thing if I say methanol plus ethanoic acid. What will be the result? The product? Methanol plus ethanoic acid. So it will be methyl ethanoid plus water. If I say propanoic acid plus ethanol, what will be the product? I wrote the name of acid first. But for ester, the name always comes, the first name is always from alcohol. So this will result in a formation of ethyl propanoate plus water. So the idea is that the first name is always coming from alcohol and the second name of ester is coming from carboxylic acid. Is it clear, this idea? If any doubt, you can ask. Copy this. I will share another link once this will end. Yes, ethyl ethanoate can also form. Ethyl ethanoate is formed when ethanoic acid react with ethanol. Ethanol plus